Hello everyone and welcome to our next session on ReactJS State Management. Introduction to State Management. Welcome to Module 15 of our ReactJS series. Today, we will dive into State Management, a core concept for building dynamic and interactive applications in React. Understanding how to manage state effectively is crucial for creating robust React applications. Now, what is state? In React, state refers to a built-in object that is used to contain data or information about the component. A component state can change over time, and whenever it does, the component re-renders to reflect these changes. State is managed within the component and can be passed down to child components as props. State in functional components. In functional components, state is managed using the useState hook. The useState hook returns an array containing the current state value and a function to update it. This example shows a simple counter with increment and decrement buttons, demonstrating how state can be updated in response to user interactions. State in class components. In class components, states is managed using this.state object and updated with the this.setState method. This example mirrors the previous one, showing a counter with increment and decrement functionality. Note how state is initialized in the constructor and updated via the this.setState method. Updating state correctly. When updating state based on the previous state, always use a function within setState that takes the previous state as an argument. This ensures that the state updates correctly, especially when dealing with asynchronous state updates. Handling multiple state variables. Using multiple state variables in functional components is straightforward with the useState hook. This example shows how to manage separate state variables for a user's name and age, demonstrating the flexibility of useState for handling multiple pieces of state. State management with hooks. React provides several hooks for advanced state management beyond useState, such as useReducer for managing complex state logic and useContext for prop drilling. These hooks allow for more scalable and maintainable state management solutions in larger applications. Now, we will cover the basics of state, how to initialize it, update it, and manage it across different components using practical examples. First, let's set up a new React project. Use the Create React App tool to create a new project named State Management Hands-On. Once created, open the project in your preferred code editor. First, we import React and the useState hook from the React library. Then, we define our simple form component. Inside the component, we declare two state variables, name and age, using the useState hook. These variables will hold the values of the input fields in our form. Next, we define a handle submit function which will be called when the form is submitted. It prevents the default form submission behavior and displays an alert with the input values. Moving on to the JSX part, we render a simple form with two input fields. One for the name and one for the age. The input fields are controlled components, meaning their values are controlled by the state variables name and age, and their changes are handled by the setName and setAge functions respectively. Lastly, we have a submit button inside the form. And that's it. we have created a simple form component using React's useState hook. Let's move on to the next step. Next, let's add a simple form component to the main app component. Open app.js. Import simple form and include it in the JSX returned by the app component. This will display the form on the main page. First, we import React and the useState hook from the React library. Then, we define our dynamic list component. Inside the component, we declare two state variables, items and input, using the useState hook. The item state variable will hold an array of items in our list, and the input state variable will hold the value of the input field where users can enter new items. Next, we define an add item function. This function is called when the user clicks the add item button. It appends the current value of the input state variable to the items array and clears the input field by setting it to an empty string. Moving on to the JSX part, we render a form with an input field for users to enter new items and a button to add them to the list. The value of the input field is controlled by the input state variable, and its change is handled by the setInput function. Below the form, we render an unordered list, that is UL tag, to display the items in the items array. We use the map function to iterate over each item in the array and render a list item, that is li tag, for each item. Lastly, we use the key attribute with the index of each item to ensure efficient rendering and updates. And that's it. We have created a dynamic list component using React's useState hook. Let's move on to the next step. Now, let's add our dynamic list component to the main app component. Open app.js, import dynamic list, and include it in the JSX returned by the app component right below the simple form. This will display both components on the main page. In summary, state management is a crucial aspect of building interactive React applications. By initializing and updating state appropriately, we can create components that respond to user actions and maintain their own data. Some best practices for managing state include keeping state as minimal as possible, structuring state logically, and using appropriate methods to update state. React Redux. Today, we will explore React Redux, a predictable state container for JavaScript apps. Redux helps manage the state of your application in a centralized store, making it easier to maintain and manage state changes across your React components. So what is Redux? Redux is a predictable state container for JavaScript apps. It helps you write applications that behave consistently, run in different environments, that is client, server, and native, and are easy to test. Core concepts of Redux. In Redux, there are three fundamental concepts. Store. The store holds the state of your application. It is a single JavaScript object that represents the current state of your entire application's data tree. Actions. Actions are plain JavaScript objects that describe what happened in your application. They are the only source of information for the store and carry a payload of information from your application to the store. Examples include user interactions like clicking a button or typing in a field. Reducers. Reducers are functions that specify how the application's state changes in response to actions. Each reducer takes the previous state and an action and then returns the next state. They are pure functions, meaning they do not modify the state directly but instead return a new state object. Together, these concepts form the core of Redux, providing a predictable and manageable way to handle state in complex JavaScript applications. Now, why use Redux with React? Redux offers several key benefits for state management in JavaScript applications. Centralized state. Redux provides a single source of truth for your application state. This centralized store simplifies data management and ensures that all components access the same data consistently. Predictable state management. By using actions and reducers, Redux enables predictable state mutations. Actions describe changes to the state, while reducers specify how those changes are applied. This approach helps in maintaining a clear and traceable flow of state changes throughout your application. Easier debugging. Redux comes with powerful developer tools that facilitate easy debugging of state changes. These tools include features like time travel debugging, which allows developers to step backward and forward through state changes, making it easier to diagnose and fix issues in complex applications. Together, these features make Redux a robust solution for managing application state, providing clarity, predictability, and powerful debugging capabilities. To begin with, import the necessary libraries for Redux and React Redux by executing the command npm install redux react-redux in your terminal. This command will install Redux and React Redux dependencies for your project. Next, import the createStore function from Redux and the provider component from React Redux into your index.js or app.js file. These are essential for setting up the Redux store and providing it to your React application. Also, import your combined reducers from the /reducers directory. Create your Redux store using the createStore function from Redux, passing in your root reducer, which combines all reducers imported earlier from /reducers. Now, render your React application using react-dom.render function. Wrap your app component inside the provider tag component, passing the store as a prop to provider tag. This step connects your Redux store to the entire application, ensuring that all components can access the global state managed by Redux. Moving on to defining actions and action creators, start by declaring an action type constant like add_to-do to represent the action of adding a to-do item. Then, create an action creator function add_to-do that takes text as a parameter and returns an action object which type set to add_to-do and payload set to text. For reducers, begin by defining an initial state object, initial state, which includes properties like to-dos initialized to an empty array. Next, write a reducer function to-do_reducer that takes state and action as parameters. Inside the reducer function, use a switch statement to handle different action types. For instance, when add_to-do action is dispatched, return a new state object using spread syntax to maintain immutability, updating the to-dos array by adding action payload. To connect Redux to React components, import the connect function from React Redux. Then, create a functional component to-do list that takes to-dos as prop and renders an unordered list, that is UL tag, where each to-do item is rendered as a list item or li tag. Use mapState2props function to map state.todos to todos prop for to-do list component. Finally, export to-do list component connected to Redux store using connect, ensuring to-dos prop is available to to-do list from Redux state. That's all for this session. Thank you.